Hello, welcome to my next lesson. So here we will solve problems for conservation of energy. Of course, mechanical energy. We have a three type. Mainly, we have energy due to motion, kinetic energy, energy due to the position, potential energy, and work done by force. And we have a potential energy of the spring. If we compress it, if we extend it. So let's solve some problems. Here we have a sky starts from the rest and slides down a 22-degree incline at 75 meter long. If the coefficient of friction is 0.09, what is the sky speed at the base of the incline? So first let's draw it. So here we have inclined plane. This angle is given 22. This is initial point. This is initial point. This will be final point. At final point, it will be moving with certain velocity v. And this is a question. Yes, we should find this velocity. What is given? The length of the inclined plane base is given L. Let's call it, and there is a friction. So, according to the conservation of energy, total initial energy at the beginning should be equal to total final energy at this point. So initially it was stationary, no kinetic energy. There is only height, yes, h, so which is equal to L times sine alpha. So we have only potential energy mgh. That's all. At the beginning, finally, it will be moving with certain velocity, so there is a kinetic energy. Plus, of course, there is a friction force. That's why some amount of energy will be lost due to the friction force or work done by friction force. So this is the first equation. So work done by friction force equal to friction force times L. Yes. What is the friction force? Coefficient of friction times normal force, which is for this case weight times cosine alpha times L. So this will be second equation. That's all. I think we can solve this problem just by using these two equations. So let's continue our first equation. Potential energy, kinetic energy, plus work done by friction force, L cosine alpha L. So mass will be cancelled. So as you see here, what is the velocity? Velocity is gravity times height minus coefficient gravity L cosine alpha. Sorry, here just one L times 2, and the square root will be equal to v. Velocity, so 2 times gravity, L, h is sine alpha, time minus mu cosine alpha. Yes, I just replaced it h by this one, L times sine alpha. So from here you can find velocity. And there was a second question, B. If the snow is level at the foot of the incline and has the same coefficient of friction, how far will the sky travel along the level? So basically, this guy will continue in this direction, yes? And here also we have a friction, same coefficient of friction, so he will stop somewhere here, yes? So what is the question? How far will the sky travel along the level? So this is the question, x. How far it will travel? Yes, before coming to the rest. So again, we need to write the conservation of energy. Initial point it was stationary, final point again is stationary. Initially there was only potential energy, finally nothing. But what happened with this initial potential energy? All this potential energy, 100%, was spent to overcome the friction force. Yes, basically. So here we should write friction force, work done by friction force on the inclined plane and on horizontal surface. Basically, on the inclined plane, work done by friction force on inclined plane is the same as this one. So let's write only work done by friction force on horizontal surface. So here we have a friction force, which is coefficient of friction times weight, normal force weight, times x. That's also from here you can find x. We'll continue with the second question. So here we have a projectile is fired at an upward angle 45 degrees from the top of the cliff. Height is given, initial velocity given. What will be its speed when it strikes the ground? So basically this is an example for motion in 2 dimensions, but we will solve it by using energy method. So this is initial point. It was fired in this direction with velocity VO, let's say, angle alpha. And this is a trajectory. It will reach the surface, ground at this point. So we need to find velocity just before striking the ground. Yes, so let's call it V2. This is initial point. This is the final point. So if you try to solve this one by using kinematics, motion in 2 dimensions, I'm sure you need to write 3 or 4 equations. But by using conservation of energy, we can solve it just using just one equation. Initial energy, we have potential energy, mg, height, and of course we have kinetic energy. That's all. Direction is not important. It has a VO velocity, that's all. It has a kinetic energy. This is initially. Finally, it will be almost at the ground, so no potential energy, but it has a velocity, so we have a kinetic energy, V2. So from this equation, V final equal to V initial square plus 2gh. As you see, there is no any information about angle, initial angle. We don't need initial angle. Next question, next problem. A ball is attached to a horizontal cord of length given L, whose other end is fixed. If the ball is released, what will be its speed at the lowest point? So I will write potential energy according to this level. So this will be my reference level. So this is initial point. This is the final point. Initially we have only potential energy. Finally we have only kinetic energy. Height becomes 0 according to this O level. That's why no potential energy. So V1 equal to 2 times gravity times height, L. And now second question. A peg is located at distance h directly below the point attached. What will be the... So this is a trajectory of the ball, yes? Because here we have a peg. So now we should find what we need to find. What will be speed? So it will be moving in this direction. Sorry. It will be moving in this direction with velocity v2. So now this will be our final point, yes? So again, we need to write initial energy. Initial energy, let's assume it to be here. So just only potential energy. At this point, we have again potential energy. So we need to take this height, yes, which is L minus 2. No, which means, so first we should find this angle, yes, this height. So this height equal to what? L minus h. So basically L minus h is radius, yes? L minus h is radius. So this height will be equal to 2 times radius, basically 2 times L minus h. Yes. So final height equal to 2L minus h, and plus, of course, it has a kinetic energy. So from here we can find V2. So let me multiply both sides by 2. 2 times GL equal to 4GL minus h plus V2 square. So this part L minus 0.8 L, this is h. So in parentheses we'll get 0.2 L. So let's continue. 2GL equal to 4G times 0.2 L plus V2 square. So here we have a 0.8 GL. So it means V2 square equal to 1.2 GL. So from here we can find velocity for the second part. So here we have three more questions. So this one will be your homework. You know what to do. This one and this one also your second homework. Let me solve last one for you. So here initial velocity given. What is its speed at point? What is the speed at this point? P. Yes. So initially it was moving, so we have the initial kinetic energy. Finally, hope it will be moving at point P. So let's say there is a kinetic energy plus height is increasing. Yes, height is increasing. So we have potential energy. If we pay attention, this h is given, this height, but we are assuming that it will be moving at point P. So we need total height. We need total height. So first we should find this small height, which is equal to L times sine theta. So total height will be equal to mass, this potential energy. Total height will be equal to small h plus L sine theta. And there is a friction force. That's why we need to add work done by friction force. So what is the friction force? Friction force is coefficient of friction force times normal force. In this case, normal force equal to weight times cosine alpha times L. And from here we can find velocity B, velocity at point B. So let's cancel masses and let's multiply by 2 both sides. So at the end we have this kind of equation: V initial square equal to velocity at point B squared plus G H plus L sine theta plus coefficient of friction times GL cosine theta or alpha. Yes, okay. So we are not sure. This velocity at point B, it might be 0. Yes, it may not reach point B. So we need to check. We are assuming that it will be moving. If we will get a negative value, it means it will not reach point B. It means friction is too strong, or initial velocity was too small, we can say. So let's solve this one. 8 square VB unknown. Let's assume gravity to be 10. H is 2. L is 0.75. Sine, what is the angle? 30. Plus coefficient of friction 0.4, 10. L is 0.75 times cosine 30. Cosine 30. So let me take my calculator and 10 times 2 plus 0.75 times plus 4 times 0.75 times. So 64 minus 26.3 equal to VB square. So velocity at point P equal to square root answer. So velocity equal to 6.1 meter per second. So it will reach point P basically. Yes, I think. No, we did one small mistake. Sorry, we did one small mistake. Here we multiplied. At this point, we multiplied both sides by 2. Yes. So here we have a 2. Here we have a 2. We need to multiply. So this point is not 26.3. Basically, it should be 2 times more. So 52. 64 minus 52. Sorry, guys. VB square. So this is wrong basically. This is wrong. Don't pay attention. So velocity at point P will be equal to 64 minus 52.6 square root answer 3.3 meter per second. So this is how you need to solve. This is how you need to apply conservation of energy. I think that's all. Yes. What is its greatest height? How you can find its greatest height? So greatest height means when velocity becomes 0 basically. So initial energy, it has a kinetic energy. Then there is work done by friction force, mu mg cosine alpha times theta L, plus it will be at certain height, so mg h. Yes. So from here we can find its maximum height. We can find its maximum height. Mass cancelled. So initial velocity squared divided by 2 minus mu gl cosine theta equal to gh. So from here h equal to v squared over 2g minus mu l cosine theta. So h equal to what was the initial velocity? 8. 8 squared to 10, 0.4, 0.75 cosine 30. So maximum height that this object can reach equal to 2.94 meters. Hope this lesson was useful. Thank you for your watching.